as Patrick mentioned, I'll be talking today about the WTF problem. I'm sure a handful of us have experienced this before. I'll start by introducing myself a little bit. I am Nicole Forsgren. I'm Senior Director of Developer Intelligence at Google in Core. And nothing I say here, it represents Google or their policies or opinions. These are all mine. Check that off the legal compliance checklist. I've been working with systems for a really long time. I started my career as a software developer at IBM. I managed large systems. I racked and stacked back when that was still a thing. I'm sure a handful of folks don't even know what I'm talking about, which is great. And then I decided that I needed to start advocating better for my teams, and I never could with leadership. So I went and did some research so I could win fights with data. Now I still occasionally win fights with data, but I also find ways to kind of communicate what's happening with our system and finding ways that we can make it easier to work with our systems because they are increasingly complex. This is what we'll be talking about today. First, we'll figure out if it's for you, and if it's not, you can just tune out. We'll talk about friction a lot today and how it's a reliability risk and what it means for us. We'll talk a little bit about AI, measuring friction, making some of the WTF visible, and then how we can advocate for improvements in our system. First of all, though, is this for me? Does this talk even matter? Has anyone here been paged for something that tooling should have caught? RIP. How many have a run book or a playbook that you don't fully trust? And how many of us here have switched out of an incident to figure out how to use the tools or figure out the logs or figure out something? Welcome. We are all in this together. By the way, we just measured our developer experience or our SRE experience. It wasn't great, but also we know that we have pretty good signal where our systems aren't working the way that they were intended. And by the way, this isn't we're just not going to talk about feelings here and vibes, but it's really important that we can kind of surface and understand where our risks are. And our experience is a property of the system. The way that we interact with that system and those complex boundaries is something that we need to think about. So I want to make the case here that this friction that we've just talked about and several other kinds of friction are actually a reliability risk. Now, I will sometimes use the term SRE or ops or developers interchangeably because of the way we work with our systems, right? We write code, we build tooling, we manage complex workflows. A lot of the things that I think about when I study and when I talk to and when I measure development work ends up applying almost even better to SRE because the complexity of our systems are much larger. We very rarely have just a very small kind of focused, constrained view of the system. And we have very similar failure modes. Cognitive load is really challenging, right? If the system itself is overly complex and we need to keep all of the pieces in our head, having a difficult to use tool actually makes it much more difficult. Being paged at odd hours makes it much more difficult to keep up with the complexity of our system and kind of understand what our mitigations should be. Tool failures are really challenging. Process bottlenecks and failures add up in ways that folks who are less familiar with the system won't see and they won't understand. I think one of the key differences here is also that when SRE systems fail, so the tools that we use to kind of manage and run our systems, the blast radius isn't one piece of code or one library or one repo. It's the entire system or sometimes every single incident that we touch. And so when we think about the scale of the work that we do, it's often much bigger. So we can understand friction a few ways. One, I touched on already, was cognitive load. How difficult is it for us to be able to concentrate on the things, right? Do we get alert noise without any context? Do we get error messages that just say error? What are the system states? Can we really understand what's happening in the system, or is it all just kind of Schrodinger's box? And mental model gaps, particularly during a crisis, right? Many times we have these black boxes where we kind of understand how that system boundary works until we really need to know what's inside of it. Tool friction is another. Any UI that fights us, whether it's a GUI or a CLI, right? Any UI that is just difficult for us to use. CLIs with flags that aren't easy to find or that are often hidden, or that, I don't know about you, I had a tool once that changed the defaults randomly every once in a while. Not the best. Dashboards that aren't up to date or that load really slowly. And it's always slower at like those 2 a.m. and those 3 a.m. calls. I don't know about you. And then process friction. How do we coordinate during events? How do we set up our war room? Which Slack channel is the right Slack channel? The one I hate the most is an approval gate that hits mid-incident. I mean, I dislike many approval gates, but the ones that appear when we're trying to move really quickly can be very challenging. And then, of course, runbooks, right? Either it's wrong, or you need to have the right context, or the words could mean different things depending on the team and the organization that you're in. All of these things slow us down. One example that I'm sure a handful of folks here have heard about is Night Capital. So for those of you who aren't aware, there were no automated deployment tests. There were no Canary rollouts. This required rolling out to 8 different servers manually. What happened? A script ended up reactivating a feature flag that had been decommissioned long ago. They weren't really using it. They were using it for something else. That rollout only made it to 7 of the 8 servers. And so system went down. They lost $460 million in 45 minutes. So if you haven't heard of Night Capital, that's why you haven't heard of Night Capital. But what we learned from this is the friction that developers and SREs and ops were feeling in their everyday work, that was the gap in the system. That's what really highlighted the challenges and the risks that we face. And friction doesn't just slow us down. It increases our error rates under pressure. I love that we just heard so much about Jevon's paradox, because as we get more automation, we can build more and more and more, faster and more frequently. Is anyone's company or organization here spouting the virtues of AI and how many lines of code we can write so quickly and how many CLs? And yet, have all of our test suites kept up? Has all of our tooling kept up? Have our processes kept up? I'm gonna guess that's a no. And we just talked about a few of them. Cognitive friction is really challenging here, because as our systems grow in complexity, not only does our understanding of the system itself need to grow, but how the system has changed from before. We've always had systems that change, but they often change on the order of weeks and months and sometimes years. So like, I think about it like when I was doing a lot of coding, like I could kind of feel the system. I could generally whiteboard it. And as we pointed out, sometimes my whiteboarding boxes would be a little different, but we all had something in common. Now, sometimes on the order of days or weeks, the system itself fundamentally changes. My whiteboard from 6 months ago might not overlap at all with what the system's doing now. Another piece here is tool friction. As we're seeing so many more capabilities pop up, and we've got like 36 AI agents and 4 different coding tools we can use and so many different interfaces and observability pieces, assuming people are building observability into these brand new systems, we keep having to switch back and forth to kind of understand and keep track of what's happening. And then, of course, the process friction. Tech is easy and people are hard. And the faster our systems move, the harder it is for all of our people and our processes and our policies to keep up. So here's the first takeaway. Open one of your runbooks this week. Just one, just pick one. And see if it reflects reality. See if it's easy to understand. Ask yourself, someone who's new on the team, 6 months or less, could they understand this? And if it doesn't, you just found your first point of friction. This is one opportunity to clean things up. And as we just heard, you might use AI to help clean it up. But this is a good place to start. And I want to call out, this is where every good friction reduction or system improvement program starts. Find one thing, look for an opportunity to improve. I think anyone here can do that. Speaking of our runbooks, AI is coming for our runbooks. We are shipping more and more code, whether we planned on it or not, and whether we planned on our systems supporting that or not. So deployment frequency is up in many places that I speak with, talk to across the industry. Now, what follows though is the incident rate, right? Many of our systems right now, we have systems and tools that capture some proportion of incidents and bugs and bad code, right? I'll make up a number, let's say 10%. As we see more and more and more code shipped, 10% is now a much larger number. So how are we thinking about capturing that? And then our on-call pressure compounds. We have more incidents, we have more friction, we have a smaller understanding of our system. So as we can see here, AI is just multiplying the friction. It accelerates the good and it accelerates the challenges that we have. And just kind of a note here for a handful of folks, if your baseline is already high, yikes. Keep an eye on a lot of this. And one example here is Replit. I'm sure many of us are familiar with this. I know everyone says AI is going to solve all the problems, but AI was here. Jason Lemkin set an explicit code freeze. No changes to the live database. In words, written down. This is not like an implied assumption of how the system should work. No changes to the database. I mean, it didn't change it, it just deleted it. AI just wiped it out. And again, the crazy thing is this was not a config flag, this wasn't a mistake, this was a straight delete. It's the same failure mode that we've seen before. It's just a new way to do it, at scale, faster. What could go wrong? Here, I think it's important for us to kind of realize and share with others, AI just makes our friction much more important and much more costly and much more challenging. It can remove some friction, but if we aren't paying attention to the friction in our systems, it's really a challenge. And it'll catch up with us at some point. AI also changes the type of incidents that we see. So when the world that our runbooks were written for, humans wrote those systems. There was at least a handful of humans who could understand and explain this system. But now that we have AI-generated systems, they're fairly opaque. And the more that we see AI interacting with these systems and changing these systems and updating these systems, the more opaque they will be. So how can our runbooks account for that? We also know that we have runbooks that have been written for known failure patterns. But as our systems are rapidly changing, we'll find more failure modes that people have never thought of before. And so we won't have a runbook or a playbook for that. Right now, maybe 2 years ago, we have diffs that are readable, right? We can understand these. I used to make jokes about, you submit 5 lines of code, you'll get 5 comments. You submit 100 lines of code, LGTM. Well, now AI is like generating many, many, many CLs or PRs that are hundreds or thousands of lines of code. And some folks say, well, this is expected. How are we going to review that? We can't keep up with the review, but how can we find ways to understand and abstract up the changes that have been made to the system? We just can't reason about them generally at all, but especially under pressure. It's really tough. So I'll note quickly here, space and DORA. For folks who have not heard of DORA before, it's a research program that I ran for a handful of years, and we have about 4 metrics that end up being a fairly good indicator of your pipeline health. So code commit to code running in production. So we can use some of these for SRE as well. When we look at deployment frequency, right? So when we're talking about the pipeline, we ask ourselves, how often can we deploy code? From an SRE standpoint, we can ask, how often are we responding to incidents? How often are we called in for change events? We can baseline that kind of a tempo, right? Lead time for changes is how long it takes to get code through a pipeline. This is a similar question for us, right? How long does it take to go from merged to deployed and stable? Speed can be a risk input. Now, I have said for years that speed and stability go together, but that was also in a world where we had systems that had tests and guardrails in place. And so if we went for speed, only for speed, and we didn't care about stability, of course they didn't go together. Well, now many of us are thinking about stability. We're thinking about quality gates, but they're not keeping up as fast as our code deployment is. Change failure rate. What percentage of our changes cause incidents? And how can we find a way to reduce that percentage? Because when the sheer absolute number of deployments is going up, a small percentage is no longer maintainable. And then MTTR, right? This is a pretty solid metric for us, but friction ends up being a big contributor here, especially when we have more and more incidents. Space is another measurement framework. Space helps us think about productivity or measuring complex things. It's often used for productivity, but we can expand that to be more complex. So it has 5 dimensions. It is also an acronym, so I can remember it. S is satisfaction. It's generally things like how satisfied am I with the tools or with the system. P is performance. That's an outcome metric, right? Is it speed? Is it quality? Activity, it's a count of things. Number of commits, number of lines of code, which is awful, but anything that we can easily count. Most people focus on activity because it's something we can easily instrument. Communication is how many meetings we're in. It can be API calls, how our systems communicate, and then efficiency. Efficiency and flow is how long it takes or like how many hops it takes to get somewhere. So when we think about this for SRE, when we look at satisfaction, we can look at an on-call burden because that will, I assume, will probably be inverse of satisfaction. We can look at our satisfaction with our tools and also psychological safety during incidents. How easy is it for folks to talk about this? And how safe can you feel when you say, I don't know what's happening because this entire code base was rewritten by AI, right? Or do we need to like fuzz around it? For performance, mean time to detect, mean time to restore, alert precision. What is our accuracy under pressure? What are our quality gates? What are our compliance gates? What are our security gates? And what does that look like? For activity, same thing, anything we can count. Toil ratio, runbook coverage, automation percentage, how many times you're on call, how many different people on the team get pulled in that were unexpected, how many escalations, how many are tied to AI. Communication, this can be incident coordination overhead. How many different places do you have to go to find information? Is it 3 Slack channels, plus the runbook, plus the email thread, plus the something, right? And then also handoff quality, because depending on how many hops it takes to get to the right person or how long it takes to resolve, how can we kind of gauge that information flow? And then efficiency. How long does it take to resolve incidents? How long does it take to find something? Are we interrupted while we're doing our work? So when we want to understand or think about how productive we are, I'm going to finger quote productive, how well we can do our jobs, I really encourage folks to look at least a few of these and have one measure from each. Even if it's a hunch, right? If you look at all the metrics that you have and they're only activity metrics, you run the risk of kind of like skewing things off because you don't have any metrics intention, right? And if folks want to game something, activity ones are often the easiest ones to game. Easier than satisfaction, even though people get real mad about CSAT. So when we look at this again, right? Your experience, because you understand and you feel that friction, is an indicator of many of your reliability outcomes. Because we can't just automate all of it. People are still at the heart of a lot of this. So we should use this like an internal diagnostic instrument. It's not just about communicating how well we did. It's about understanding our biggest opportunities to improve, especially as our systems are kind of growing in complexity. So some things that I've seen as AI is changing more of our workflow. Efficiency often goes up because we can hand off many things to agents or AI or LLMs. But then we have risks from trust. Or sometimes people will slow the system down because they no longer trust it. Their intuition, which we never fully understood our systems before anyway, right? But our intuition feels very, very different now. From satisfaction, we often wonder if the AI output is trustworthy, or we have a brand new tool interface that is just really hard to use. For communication, it's often much harder to hand off context. In some ways, we can use AI to summarize and provide updates for folks during a handoff, but now the volume of information has just gone up exponentially. How can we think about that and manage it? For performance, there's a new risk for, again, these opaque failure modes. We used to know the system, now we just don't. Another takeaway here, talk to one of your colleagues. Ask them, here I'm saying what friction impacts them. When do you swear at your systems? What is really hard? What is the thing that you are mad at the most? Their answer is probably different from yours. And that also invites opportunities for improvement, right? If it's the same thing, that's a good indication that even if the N is 2, we should probably improve something. If it's different, that's really interesting. Under which conditions do they find it? What's their operating model? I'll say I've been at a few companies where I was absolutely swearing at a particular tool every day. I was so mad, just always using computers in anger. And someone else just thought that was bizarre. Well, he'd worked at the company for 20 years, so he had all of the shortcuts. He had all the short keys memorized that you could not find anywhere. And he had 100 shortcuts sort of built around and mini automations built around that he forgot he built, but they were still there. And so that surfaced an opportunity for us to realize this was a big risk for any new hire that we had coming into the company. So here, I think one thing we should think about is making our WTF visible. We can't fix what we can't measure, or at least we can't understand how well the fix has landed, and we can't fund it if we can't explain it, right? We can't get resourcing. So I would like to propose a new North Star metric. Mean time to what the... I think it's catchy. So here's the proposal. How long it takes to go from the alert to I understand what's happening. So it's a little different from detection, and it's different from resolution, but with the complexity of our systems growing, this is my proposal. I'm sure it'll take off.
We have stickers of it already.
Oh, there's stickers already. I'm very excited. Thank you, Liz. The reason I like this is because it can act like a leading indicator of our systems and how brittle they are. Because if our mean time to what the grows, it will climb first, and then MTTR, right? For now, we'll have some things where MTTR is fine, right? We'll have our generic mitigations, we can turn it off and turn it on again. We'll have a handful of things that kind of work. But the longer it takes us to understand what's going, we can start catching that earlier, before our MTTR goes up. So here are a few starting points to help kind of surface our mean time to WTF. First is add something in your retro. It takes 5 minutes. Add a friction contribution field or friction source field, right? One field, no new process. Where was the biggest source of friction? You can also do an on-call survey. You set this out quarterly, 2 or 3 questions. What slowed you down? What would have helped? What did you have to invent? What did our tools not cover? There are a few ideas here, right? When did you swear the most? That one's my personal favorite, but it doesn't make it past every corporate policy. And we can do a toil tracking sprint, right? A lot of companies do fix-it weeks or hack weeks. We can do one time box sprint, kind of gathering together the things that we've captured about our biggest sources of friction, and we can start knocking them out. And frankly, we might not even need a full sprint. This might be where we can have the robots come in and help. They can help identify these sources, and they can help improve them. And That's when we want to fix it. You could also do a sprint, and I'll kind of finger quote sprint here, just to have everyone write down and track all of the sources of friction, just so we have a list. Just to give us better visibility and understanding of where our biggest sources of friction are, because those are going to be the things that make it difficult to continue growing at scale. So for this section, start measuring things. Here are a few ideas. Start a friction log just for yourself. Make note of all of the times things aren't working quite the right way or quite the way you expected. Time your MTWTF just once. Next time you have an incident, just notice how long it takes to understand. And some cases, we won't understand it until long after MTTR hits. And then we can also just declare a toil hour. Just log all of the friction for everyone on your team. And this can just be about capturing an inventory first. We're not asking for much. And I don't know about you, but every person in tech I've ever worked with is super excited to tell you about all of the stuff that sucks. This is great. So we're on the same team. Okay, now that we have an understanding and idea of where our opportunities are, and we may have fixed a couple of them, now we can make the case, right? Because I don't know if y'all have ever hit this, but I have this great idea. I know it's gonna be great. I know it's important. And then I go ask for resourcing and funding, and I get a, nah, or do you have a business case? Or what is the math? Have we ever hit this? See, this is the challenge, because when we're doing our jobs right, people don't remember us. We don't really exist. As soon as something is wrong with the system, then we're everybody's best friend. So I will also say sometimes I time this around an incident or around something that is high risk. So then people care about it a lot. But this is also big, right? So here's a couple research pieces here. SISQ found that the cost of technical debt annually, and this I think is as of last year, was $1.52 trillion for the US. McKinsey found that 40% of dev budgets are spent on avoidable rework. These are sources of friction. Another study found, I think this was another McKinsey study, developers feel 68% productive. Well, they did the math, and that missing 30-ish% is about 300 billion lost in GDP in the US. There's a lot of opportunity here, and as our systems start moving faster and faster, and as the scale and complexity increases, this will only go up. So we can make the argument, this isn't about us being happy, right? Someone's like, oh, well, let's do a DevSat survey or an SREsat survey, and then execs are like, I want people to be happy, but I mostly want my systems to work. This is about remaining a competitive actor in whatever industry you're working in. So we can reframe some of this. Now this right here is about talking to our peers, right? Here we want to talk about experience. If I talk about productivity, look, any metric will be gamed, right? But if I'm talking to someone else and I want to understand and I want to learn about their system, this opens up the conversation because it's not a threat. I'm not trying to assess their productivity. I want to understand what it's like to use the system. Productivity often implies that we're measuring individual output, lines of code, number of PRs, number of CLs. But when we ask about experience, I want to understand what it's like to use the system. I want to know what tools you absolutely love, because then I want to use them. But I also want to know what's difficult and challenging for you. I want to know about the obstacles. Leadership, now we talk about leadership and productivity. We just want to make sure people are working hard enough, which is weird, right? But we can reframe this for leadership to say, we want to remove what's slowing us down. We want to enable more people to keep working faster. We want to make sure that we are bolstering our systems so that they can support this exponential workload that you see coming, right? One thing I'll note here, your stakeholders will often fund reliability if we can frame it the right way. They won't always fund happiness, which isn't great because we know that people who are happy in their jobs, when they're satisfied, when they have good psychological safety, they do better work. But it's hard to make the business case for this. So let's find a way to anchor things in reliability. So for the business case, we can talk about a developer experience, but it's much better if we can frame it in terms of reliability once we've already gotten that data. And we can connect things together, right? And I think this work back is what helps. We can start with revenue impact or profit impact, right? Do we have cost of downtime? Now, what's our SLA risk? What does that mean? Are there financial implications to our SLAs? That works back into a higher change fail rate, slower MTTD, MTTR, and then we can talk about friction. If we just try to talk about friction, that jump can be challenging because for someone who isn't running systems all the time, figuring out how to get Outlook up or get the calendar invite fixed, the line isn't direct for them. They don't necessarily feel in their bones how really difficult systems can lead to these types of outcomes. But we know this. So here we can say, we're proposing a better system. Not just SRE satisfaction, but we'll get that too. One thing I will note here, when at all possible, anchor it to something that they already own, that already exists, and that someone who is not you came up with. So one example that I included here is a downtime cost estimate. How much does it cost for downtime? How do they model it? Where does that come from? Or do you have a risk cost or a reputational cost estimate? What are the types of things that exist? What is your fully burdened engineering cost estimate? If we come up to it, it's challenging. Go grab lunch with someone in finance. Ask them a couple questions. Help them understand and really see and feel that we're trying to help them out and we really value the work that they do. And then we can build our math on top of that. I'll also mention, sometimes we don't need a cost piece. There are a few strategies to making our business case. Number 3, dollar impact for sure, right? And when we do dollar impact, like I said, use somebody else's number. We can use simple data, just clear action. So for here, something like progressive disclosure. If I know this system's broken this way, what's the next question I would ask? What's the next piece of detail to kind of breadcrumb trail someone along? We are often used to looking at dashboards with 100 metrics, but because we look at them all the time, they make sense. Have you ever shown an exec one of those dashboards and just watched their eyes glaze over? You should do it sometime, it's wild. And then we kind of walk them through what this means, and if these look the same way, it's fine, and if these look different. But if you just give them that dashboard to look at all the time, they'll either not look at it all the time or they'll walk away with wildly different conclusions. So kind of help walk them through what those questions are. Another thing that's super powerful is just visibility, just capturing information, which is why I started with the suggestion of just write down something that doesn't work for you and your team. One example that I love was Dave Anderson at Amazon. So they asked him to improve platform error rates. Hey, Dave, go fix this. By the way, you have zero authority over any executive. I think a handful of us have maybe been in this case where our responsibility, is the reliability of the systems, but we also can't tell all the executives what to do. So what Dave did was very clever. He pulled together all of the data, and he published a monthly S-team report. So the S-team at Amazon is the directs for the CEO, right? So for the execs, he made a report. Error rates by team, and he noted the VP who owned those error rates. No orders, no actions, he just published it. Within the first couple of weeks, directors and VPs raced to figure out how to get themselves off the report. All it was visibility, right? Which I think there's a lot of power in because we understand our systems. We understand what that looks like. There can often be a couple clever ways just to surface that and drive some action. The note I had here, the measurement doesn't have to mandate change. It should just make status quo uncomfortable. That can be one good pointer to what types of things we want to capture and display. What is status quo, and what should be uncomfortable? How can we make that uncomfortable? So one takeaway, one thing that you can do now is find out your org's cost of downtime number or cost of something number. Like I said, take someone from finance to lunch. For bonus points, find out how it's calculated. That'll give you really interesting insight into how the company thinks about these things. So I've chatted with probably hundreds of teams across the industry, internationally, and it's been really interesting to see. Some companies have very, very complex cost models. I won't say advanced because people make the choices that they make. But it was very clearly understood, like it included reputational risk, it included recovery time, it included all of the incident reviews, it included customers impacted, it included forecasts for future revenue. I've chatted with other large organizations where their cost of downtime is the number of credits that they issued to customers, which is not going to be complex, right? It's going to be limited in very strategic ways, but that also tells you the way they think about this, in large part, is how it impacts large key customers. So that helped inform some of the strategies around how we wanted to communicate risk or friction. All of it was important, but in particular, how did it affect the last N number of customers they had ever issued cloud credits to, or the customers they really did not want to have to issue cloud credits to. Because then we can just say every hour of downtime costs us this much money. Friction is costing us this much time. I can draw a line between how difficult our systems are to use and how the complexity is growing and how it will impact that downtime. Okay, here's our TLDR as we wrap up a little bit. If you haven't been paying attention, look up now, take a picture. You'll get full credit. Back when Twitter was around, I'd say to post this to Twitter, but RIP. Quick reminder, one thing we can do today, open a run book, see if it's real. Another one, is talk to a peer. Ask what slows them down. Maybe compare to yourself. Number 3 is to start a friction log. Just ask folks around the team. It could be an hour, it could be a week. Look for some patterns. Feed it into Gemini or Claude or ChatGPT and ask it what patterns are. Look for some opportunities for AI to assist some of those pieces. On one incident, time your WTF on a real incident. And maybe ask a couple other folks to do something similar. How long did it take them to understand the problem? Number 5, declare a toil hour. Inventory first, and then fix later. Even just having an inventory can be helpful to identify patterns. And then number 6, ask someone in finance what the cost of downtime is and how they calculate it. It's nice to have some of these numbers in your back pocket sometimes. So, another way to look at this. For anyone here who's an IC, you can also map your workflow for a week. Where are the places where you're losing 30 minutes? Write it down, ask someone else something similar. For anyone here who's a team lead, you can do a quick 30-minute retro. What slowed us down that wasn't the work? Was it a tool? Was it a policy? Was it a process? Was it a run book? Was it poor documentation? Was it missing documentation? And for leaders, just set up 3 listening sessions. It says listening sessions. It sounds very proper. Go grab coffee with someone. You can napkin math the cost of some of the friction points that get surfaced. I do want to mention, I just co-wrote a book with Abhinoda. The QR code will get the book if you want. I'd appreciate it. If not, online we have over 100 pages of free rubrics and spreadsheets about understanding friction, identifying friction, looking for opportunities to improve it. If you want to do a survey, we have a lot of free survey questions and a full survey structure. If you're looking at improving or changing things across an organization, we have guidelines and playbooks for if you're doing this as an individual contributor and you're following a grassroots process. if you are the director or the senior director or the VP of something and you have an executive mandate, or if you're somewhere in the middle. So there's a lot of good free resources there, interview guides, all sorts of stuff. So thank you so much for the time.